In this video, we are going to use Excel to conduct a logistic regression analysis on adult offense. The independent variable will be the age at first delinquent offense, drinks per month, and marijuana use per month. Okay, we will be focusing on the overall model, the AUC of the model, the coefficient, especially the direction of the coefficient for each independent variables, and the significance for each independent variables. To do that, we need an add-in called regressive. So we click the regressive. Before we can click the logistic regression, we have to first set up the data. So although the data is showing here, but we need to let the add-in knows that the data is here. So we click select data and select all the data we have here. Okay. When they are selected, click create names. Okay, since we have the labels on the first row, we just put the names of values in the top row. Click OK. Well, it seems nothing happened, but now the data is ready to be analyzed by this add-in. So in order to conduct a logistic regression, click the logistic regression on the left corner, and our dependent variable will be adult offense, right? Independent variable will be age, check age at first, the delinquent offense, drinks per month, and also marijuana use per month. Okay, here. And also take a look at, we will have the confidence level at 0.95. That's fine, that's good. We have the values of the dependent variable as 0 and 1. Adult offense 0 and 1. Good. And we need some extra descriptive information. For example, we can put a classification table here. We also can put a ROC curve here. Well, you don't have to, but this will give you some more information, so it can allow us to double check it. So we click the run. In the bottom, it goes to two things. It pumps out two things. One is the model summaries. As we mentioned, the R-square, adjust R-square in logistic regression are not really used for interpreting something, so we don't really take a look at that. Then we go into the model one. The model one actually give you some information. I'm going to insert a text box so I can type something here. Okay, so let's make it bigger. So what you will see here is that we have we have the logistic regression stats, and it's the summary of the model itself. Now among here, R-square, adjust R-square, we don't really look at that in the logistic regression, but we are going to looking at the ROC area. The ROC area, or also it can call AUC, or the area under the curve, right? It's the same name, is 0.87. You can also find its number down here in the ROC curve. So the ROC curve area under the curve 0.87. So this one is a good thing that tells us whether our model is good or not. As we mentioned, that if the AUC is between 0.9 to 1, right? This will be suggesting that the model is an excellent model. If it's going to be the 0.8 to 0.9, this will be a good model, indicate this is a good model. If it's a 0.7 to 0.8, this indicate a very failed model. Okay, not so good, but okay. And if it's less than 0.7, that this model will be a poor model, a bad one. So here we don't really have a very high one, but we have, what we have here is 0.87, right? 0.87 goes between this area, which basically means that our model is a good model. Okay, and then we can double check this one by clicking the plus here Okay, when you click the plus here, analysis of deviance, you will see that we have the ROC area, and most importantly, we have this p-value. This p-value also indicates the f-test. The f-test in the regression analysis, whether it's a logistic regression or linear regression, OLS regression, it basically means that we test a model with all independent variables versus the model with no independent variable. Independent variables or independent. Okay, so the f-test basically tests the model with all independent variables and the model with no independent variables. Okay, and the hypothesis is that there is no difference. The alternative hypothesis will be there is a difference. So what we have here is a p-value. The p-value is 0.039. Okay, which is less than 0.05. So what we do is that we are going to reject the non-hypothesis. The non-hypothesis means those two models are the same. There is no difference, but we reject it. So basically means that there is a difference between the model with all independent variables versus the model with no independent variables. And combining with the AUC 0.87, we can say that our model that has 4 independent variables is a good model in predicting adult offense. Okay, now we're going to take a look at each of the independent variables here. So we're focusing on the coefficient, and also we're focusing on the p-value. So we just took, I'm not going to talk about everything, but let's just talk about 2. Okay, the first we 2 examples. Age. So the age is negative 0.232. Okay, how to interpret this one? There are a few ways. There are more mathematical ways to interpret that. So the mathematical way to interpret that is that we are going to use this number to calculate something we call the odds ratio. I just put it here. Okay, the odds ratio is basically we are going to use the function formula math and going to use the exp. Okay, the number we put is the age, negative 0.232. Okay, and this is the odds ratio, and interpret that we need to use a 1 minus this odds ratio. Okay, so we have 2 numbers here. So the first way we can interpret is 1 unit increase in age multiplies the odds of conducting adult offense by 0.9793. Okay, which sounds a little bit weird. So we are going to use the second mathematical way to interpret that is 1 unit increase in age is associated with a decrease of 21%, because 0.207 is like a 21%, right? A decrease in the odds of conducting adult offense. Okay, so these are the 2 mathematical ways that we interpret that. But in academic papers, you don't really see this very often. You may see this sometimes, but not really often. The most often thing is that we care about the direction. So the age for the direction is a negative. Okay, so what we can say is that age is negatively related to whether a person conducted adult offense. Okay, age is negatively related to whether a person conducted adult offense. Okay. And then we're going to focus on the p-value or the significant, right? So the p-value or the age, we have this coefficient interpret already. We have the p-value here. The p-value for the age is 0.766. It's larger than the 0.05. What does that mean? So if it's smaller than 0.05, we will reject the null hypothesis. If it's larger than 0.05, we don't reject the null hypothesis. The null hypothesis basically talk about the age is not a significant predictor. Now here we cannot reject the null, so we have to accept the null hypothesis, right? The null hypothesis is age is not a significant predictor or variable or factor in predicting adult offense. Okay, though it has some kind of a mathematical way that can do something like this. We talk about reduce the odds ratio, but it's not a significant impact. So in general, age is not statistically significantly related to the dependent variable, which is adult offense. Now let's take a look at the age at the first delinquent offense. Okay, so here what do we have? The coefficient is negative 1.050. Okay, again, if we want to interpret this in a mathematical way, so we have to use the odds ratio, right? So we use the formula math exp and put this negative 1.050 inside of that. That's the odds ratio, and again we need 1 minus this odds ratio. We'll get another number. Okay, so here we can mimic what we have. 1 unit increase in age at first delinquent offense. Okay, multiplies the odds of conducting adult offense by 0.35. Sounds weird, but also we have another way to make it more a better understanding for that is 1 unit increase in age at first delinquent offense is associated with a decrease of 65%. That's where the 0.65 is. 65% in the odds of conducting adult offense. Okay, these are two mathematical ways to interpret that, but in practice most likely you are going to see the sentence like the third one is age at the first delinquent offense is negatively related to whether a person conducted adult offense. Age at first delinquent offense is negatively related to whether a person conducted adult offense. Okay, that's what more often you will see in practice. So now we're going to the p-value, right, to see if this is a significant predictor or not. The p-value of the age is 0.039. Okay, which is less than 0.05. So if it's less than 0.05, we are going to reject the null hypothesis, which is that it is not a significant predictor. So when we reject that, we say it is a significant predictor. So what we have the conclusion here is age at first delinquent offense is a significant predictor or variable or like factor in predicting adult offense. Okay, so age at first delinquent offense is a significant predictor variable factors in predict adult offense. So this is a very important conclusion that we can see from these results. Okay, so I'm not going to do the drinks per month and marijuana use per month, but as you can see, the drinks per month is positively related to the dependent variable, right? Marijuana use is negatively related to dependent variable. However, they are both not significant predictors. So basically means that among those 4 predictors, the one that is actually useful in predicting adult offense is the age at the first delinquent offense. Okay, that's the very important conclusion. So from this conclusion, what we also know is that age at the first delinquent offense is a significant predictor, and it's negative. So which basically means like the kids who like commit first delinquent behavior at age 11, and there is another kid. There's a kid commit there is a kid commits the first delinquent offense at age 11, and there are another kid commits the first delinquent offense at age 14. Let's say that. Okay, so we have 2 kids, and based on the findings, we will have the prediction is that the first kid who commits the first delinquent offense at 11 are or is more likely to conduct adult offense compared to a kid commits the first delinquent offense at age 14. Okay, I'm just going to write this down. So a kid who commits the first delinquent offense at age 11 is more likely to conduct adult offense, more likely to conduct offense compared to a kid commits the first delinquent offense at age 14. Okay, so you can switch to other things like kids who are age 11, and the other kids who are at age like 13. So it's the same. Okay, it's the same meaning. Is that the earlier the kids start doing some delinquent offenses, the more likelihood that this kid will be doing some adult offense in later age. Okay, that's the thing we found out. Now, in terms of the other 3, the kids' actual age, the drinks per month, and the marijuana per month, they are not as significant predictors. So in stats or statistically speaking, we don't see them as important things. Okay, so the important things here when we're going to predict the adult offense is the first delinquent offense, the age at the first delinquent offense. Okay, that's it.